Let's take a look at 3 exam questions regarding the trapezium rule. Again, only valid for students taking P2, not for P3. So this one is winter 2014, question paper 21. Use the trapezium rule with 4 intervals to find an approximation to integral between 1 and 5 of modulus of 2x minus 8 dx. So 4 intervals. 4 intervals means what? It means that on this range from 1 to 4, you are going to divide it by 4, right? Which means that you'll have strips of length 1 unit. So you already know the value of h over here is 1, right? What else do you need to know? You need to know the values of y0, y5 in this case, y5 in this case, and for all the other values of y over here, all right? So you will have a total of 5 heights, the f of 1, f of 2, f of 3, f of 4, and f of 5. I just plug in the values of f over there, and these are the results. And then I just apply the formula. So the area is going to be h over 2, f of 1 plus f of 5, the first plus the last, plus 2 times the sum of all the others. All right? Just plug in the values, and you'll get 27. So the integral of this is going to be 27 using the trapezium rule. That will be the answer for this question, 3 points. Another one, this is paper 2, June 2005, May-June 2005. This is the question. The diagram shows the part of the curve y equals natural logarithm of x over x for x between 0 and 4. The curve cuts the x-axis at A, and its maximum point is M. So cuts it over here, and the maximum point is over there. Write down the coordinates of A. The coordinates of A happen when y equals 0. So if you are going to do y equals 0, whoops, where is it? It's here. You equal it to 0, so this only happens if the natural logarithm is 0, which only happens when x equals 1. So you already know that that is 1, so the coordinates are 1, 0. Then, let me just go more over here. Then, show that the x-coordinate of M is E, and write down the y-coordinates of M in terms of E. Okay, so if it is the maximum point, what you have to do? You have to do dy by dx and equal it to 0. Differentiate that, you have the division between 2 smaller functions. So you just do the first times the second one, or basically the denominator times the numerator differentiated minus the numerator times the denominator differentiated divided by the denominator square. You already know this for a long time. Do it, and this is what you get. Equal this to 0. This only happens if 1 minus logarithm of x is 0, or natural logarithm of x equals 1. And once you get that, you just do the opposite of the natural logarithm, which is the e. In this case, I just put both what you have on the left-hand side of the equal and what you have on the right-hand side of the equal, both to as the power of e. So this can cancel each other out. So you just have x equals e. Then you do f of e to get the value of y. And if you plug it in the original function, then you're going to have natural logarithm of e over e, which is just 1 over e. All right? So you already have the x and y coordinates of both. Then use the trapezium rule. This is the part that relates to this topic. Use the trapezium rule with 3 intervals to estimate the value of this. 3 intervals. What is the range? Between 4 and 1. The range is 3, so 3 divided by 3. You have strips of length 1 unit. Okay? So now you have to do the various heights. If you have 3 strips, you have a total of 4 heights. For 1, 2, 3, and 4, just plug in these values in the original equation, and you have here the heights in terms of natural logarithm. Then apply the rule. H is 1. You put the first and the last, plus 2 times all the others, which in this case is just 2. Plug in the values, and you have correct to 4 decimal places this value over here. But you needed how many decimal places? 2 decimal places. So that's basically just 0.89. Finally, state with a reason whether the trapezium rule gives an underestimate or an overestimate of the true value of the integral. Just by looking at the function and the trapeziums that you could write between the function and the x-axis, you'll see that the area that you just calculated is an underestimate of the true area of the curve, because it's not contemplating these little parts over here in white that are in between the top part of the trapezium and the curve. So the answer is that, as seen on the shaded area above, it is an underestimate. Let's go to the last exam question. It's Spring 2014, question paper 21, question 6. Show that the integral between 6 and 16 of 6 over 2x minus 7 dx equals natural logarithm of 125. All right, so we can very easily put a 2 over there if we just look at 6 as being 3 times 2. That's what I did. Put the 3 outside, and then I have here 2, and 2 is what? 2 is the outcome of differentiating this. So now just apply the rule that you just learned in this lesson, in the previous lesson, I mean. And this is going to be natural logarithm of 2x minus 7 between 6 and 16. Substitute, and you'll have natural logarithm of 25 minus natural logarithm of 5. You have a difference of logarithms. That's basically the logarithm of the quotient of these two. 25 divided by 5 is 5, multiplied by the 3 that you had before. You can put this 3 on top, I mean, as the power of the 5, and 5 cubed is 125, and you have proven the value that you wanted in the first place. Then you have to use the trapezium rule with 4 intervals to find an approximation to this value over here. So range 17 minus 1 is 16, divided by 4. The result is going to be strips of unit 4. Okay. Time now to get the height of the different strips. If you have 4 strips, you need a total of 5 heights. All right, starting with 1 and going by 4. So 1, 5, 9, 13, and 17. Just plug in the values and see what you get in terms of the logarithm. Then apply the rule. H is 4, F1 is 0, F17 is natural logarithm of 17. Natural logarithm, no, just logarithm base 10 of 17. The others are multiplied by 2. You just needed a value correct to 1 decimal place. Was that it? No, 3 significant figures. Okay, so just plug in that in a calculator. You got that result for decimal places, rounded to just 1, so that you have 3 significant figures, and the result is 13.5. And this will be it for the trapezium rule.